Hello, my dear students. Welcome to my YouTube channel that's Concepts of Chemistry. So, today's topic for the lecture is normality with some numericals. So, what is exactly normality? It is the one of the concentration term to measure the concentration of solute in solution, just like molarity and the molality. So, let us discuss what is normality. Normality can be defined as normality can be defined as number of gram equivalents of solute. The number of gram equivalents of solute dissolved per liter of solution. Dissolved per liter of solution. That stands for normality. So, I am representing the normality in the formula way. So, normality, it is represented by capital N, will be equal to the number of gram equivalents of solute divided by volume of solution, and the volume of solution must be in liters. That stands for normality. Now, what next? Normality capital N will be equal to the gram equivalents of solute is represented by G EQ is of solute, so I am writing B. So it's the gram equivalents of solute divided by volume of solution in liters. Now, normality will be equal to the gram equivalents of solute divided by volume. If volume is in milliliters, you have to convert your volume by dividing it with 1000. So what next? My normality comes out to be gram equivalents of solute divided by volume. If the volume is in milliliters, now you have to take this 1000 to the numerator into 1000. So that's the formula for the normality. Now let's discuss about the units of the normality. Now I'm talking about units of normality. The unit of normality is gram equivalents per liter. So that's the units of normality. So in normality there is a term that's a gram equivalents of solute. Now first of all let us solve what is exactly gram equivalents. Now I am discussing what are gram equivalents of solute. Gram equivalents of solute will be equal to the given weight of solute, given weight of solute, or the weight for which you have to do the calculation, that's the given weight of solute, divided by equivalent weight of the solute. Equivalent weight of solute. You can represent it like gram equivalents of solute will be equal to the given weight is always represented by capital W, and that's for solutes it's a WB, divided by Equivalent weight is represented by EQWT, equivalent weight of solute, so I am writing B. So gram equivalents of solute comes out to be given weight of solute divided by equivalent weight of the solute. Now here the term is equivalent weight. Now what is equivalent weight? Now let us discuss about it. Equivalent weight of solute will be equal to the molecular weight of solute divided by n factor. So the molecular weight is represented by capital M, that's mb divided by n factor. Now let us discuss what is n factor. So I am talking about now n factor. N factor is total positive valency of the compound or solute whose normality we are calculating. So n factor is the total positive valency of the solute. So I am giving you some examples how to evaluate the n factor. First of all, I am taking some acids. An example, now I am talking about some acids. For acids, my n factor will be equal to the ionizable hydrogens. So let us take an example. First of all, I am talking about sulfuric acid, H2SO4. So let us calculate how many ionizable H or total positive valency is in H2SO4. So the structure of H2SO4 will be SN sulfur, double bond O, that's my OH, here's my OH, and that's my double bond O. The ionizable hydrogen are those that are linked with oxygen in any molecule. So here this hydrogen carries +1 charge and this hydrogen also carries +1 charge. The total positive charge is here is +2. So n factor over here is 2. So the n factor for H2SO4 is 2. Now let us take another example. Now I am talking about H3PO4. That's my H3PO4. The structure of H3PO4 will be P. That's my double bond O. That's my OH. Again that's my OH. And that's my OH over here. Now let us calculate the total positive charge. This hydrogen is a +1. This is also +1. And this hydrogen is also +1. So total positive charge is +3. So my n factor is 3 for H3PO4. Now I am giving you another example. Let's talk about H3PO2. H3PO2. Its structure will be P double bond O, OH, OH, and one hydrogen over here. So first of all, my dear students, this hydrogen is not ionizable because it is directly linked with phosphorus. The ionizable hydrogens are those that are linked with oxygen. So this is not ionizable, so we will not even count it in the positive valences. So here it comes out to be +1 and +1. So this thing comes out to be only +2. So n factor comes out to be 2. So students usually makes the mistake by counting directly the number of hydrogen in the molecular formula and they take it as an N factor. No, my dear students, first of all, you should know the structure of that compound, and in that compound, the hydrogen which is linked to oxygen is ionizable. In H3PO2, the one hydrogen is linked with phosphorus directly, so that is not ionizable. So it comes out to be total positive charge of +2, so N factor comes out to be 2. So now let's talk about some base. Now I'm giving you two examples of bases. Let me take an example of, first of all, NaOH. NaOH. Here I know that OH carries complete -1 charge, so the sodium will carry a +1 charge. So here total positive valence is +1, so my N factor is 1 for NaOH. Let's talk about CaOH whole twice. First of all, it will dissociate like we are having OH negative to be 2 in number, so my calcium will carry 2 positive charge. So here my total positive charge comes out to be +2, so my N factor is 2 for calcium hydroxide. So N factor is 2 for whole calcium hydroxide. Now let me take some salts. Now I am taking examples of salts. I am taking example to be copper chloride, CuCl2. It will dissociate like Cu2 positive plus 2 times Cl1 negative. So here the total positive charge is +2, so the N factor is 2 for whole CuCl2. Let me take another example. I'm talking about now AgNO3, that's silver nitrate. It will dissociate like Ag positive and NO3 negative. So here positive charge is +1 only, so my N factor is 1 for whole AgNO3. So here, my students, I have given you some example to how to evaluate the N factor of a specific compound, which you have to put it over here to get the equivalent weight. Then this equivalent weight you have to put it over here to get the gram equivalence, and then this gram equivalence value you have to put it over here to get the exact normality. So now let us find a relationship between the normality and the molarity. So the formula for normality was normality is equal to the gram equivalence of solute divided by volume of solution, and if it is in ml, you have to multiply our formula with 1000 because we have to convert our milliliters to liters. Now, what was the gram equivalence? Gram equivalents were given weight of solute divided by equivalent weight of solute, that's the volume. If it's in ml, you have to multiply this over 1000. So what next? Now I am putting the value of equivalent weight over here. It comes out to be given weight divided by, what's equivalent weight? That's molecular weight divided by N factor into V ml into 1000. In next step I am moving my N factor to the numerator, so it comes out to be WB divided by MB into V, it's in ml, so it's into 1000 into N factor, and which is equal to the normality. Now observe it very carefully. What you have to observe, that this value this value is exactly the formula for molarity. It comes out to be molarity. So molarity into n factor will be equal to the normality. So I have found a relationship between the normality and molarity. That is, molarity into n factor will give me normality. So hopefully, my dear students, you understood the topic. So let us solve some numericals. First of all, the first numerical, what is saying? Is saying that a solution of oxalic acid, the molecular formula of oxalic acid is given. It is prepared by dissolving 0.63 gram of acid. First of all, my dear students, what is oxalic acid over here? My oxalic acid is solute. So it is prepared by dissolving 0.63 gram of acid. So that's the given weight of solute. So the given weight of solute comes out to be 0.63 grams. It is dissolved in 250 centimeter cube of the solution. I got the volume of solution to be 250 centimeter cube and the ml is the same thing. What I have to do? I have to evaluate the normality. So first of all, let us calculate the molecular mass of oxalic acid. What's the molecular formula? It's C, that's my double bond O, and the OH, and C, that's a double bond O and the OH dot 2H2O. So how many carbons are there? 2. So that will be 12 into 2. Let me take some another ink. Now, how many hydrogens are there? 1 and 2. So it's 1 and 2. How many oxygen are there? 1, 2, 3 and the 4. It comes out to be 16 into 4. Now, plus, let's talk about now water. In water, how many hydrogens are there? That's 1 into 2. How many oxygen are there? Only 1. It's 16. Now, how many water are there exactly? Water are here 2 in number. So I have to multiply the weight of one hydrogen with 2. So this evaluation comes out to be 126 grams. That's my molecular weight of solute. So now let's talk about the n factor. Now we are talking about n factor. Let's come back to the exact formula again. Here, first of all, how many ionizable hydrogens are there? This is the plus 1. This is the plus 1. I got the total charge to be plus 2. So my n factor comes out to be 2. Hopefully, my dear students, you got this. What I have done, first of all, I have calculated the total positive charge. So that's my n factor. The total positive charge is my n factor, that is 2. So now we are going to first of all evaluate the equivalent weight of the solute, because we need it in the formula of the normality. So let's talk about it. First of all, equivalent weight of solute will be equal to the molecular weight of the solute divided by n factor. How much molecular mass we have calculated? It's 126. That's my 126. I'm putting it over here. That's a 126 divided by how much n factor we have calculated? It's 2. So I'm putting it in my formula. It's 2. My equivalent weight comes out to be 63 grams. So that's my equivalent weight. Now let's talk about the gram equivalent. Now I'm talking about gram equivalent of solute. Gram equivalent weight of solute is given weight of solute, that's WB divided by equivalent weight of solute. What's WB over here? In question is given 0.63 gram. which I'm going to put it over here. It comes out to be 0.63 grams divided by, what's my equivalent weight that I have calculated? It's 63 grams divided by 63. My gram equivalent weight comes out to be, gram equivalence of solute comes out to be 0.01. So I got the gram equivalents. What next I have to do? Now I'm putting the formula for normality. The normality is gram equivalents of solute divided by volume of solution, and if it's in milliliters you have to multiply it with 1000. So my dear students, how many gram equivalents we have calculated? That's 0.01. So I'm putting it over here, 0.01 divided by, what's the volume of solution given in the question? That's 250 ml. This is 250 ml is given in the question. So I'm putting it over here. So it comes out to be 250 into 1000. My normality comes out to be 0.04. So that was the numerical. Hopefully my dear students, you got the question. First of all, I have evaluated the n factor for oxalic acid, which came out to be 2. I have used that n factor in calculating the gram equivalents of the solute. I have used that n factor to calculate the equivalent weight of the solute. Then I have used that equivalent weight in calculating the gram equivalents of the solute. Then I have evaluated the normality. So my dear students, please do have a look. What I have exactly done, I'm explaining it again. First of all, I have evaluated the n factor. I have used that n factor to calculate the equivalent weight of the solute. From that equivalent weight which I have calculated, I have used that equivalent weight to calculate the gram equivalents of the solute. That gram equivalents I have used to calculate the normality of the solute. Let me delete it again. I'm explaining you again what I have done over exactly here. So my dear students, first of all, in this numerical, I have calculated the molecular mass of the solute. Then I have evaluated the n factor of the solute. Now I have used that n factor to calculate the equivalent weight of the solute. Then I have used that equivalent weight to calculate the gram equivalents of the solute. Then I have used that gram equivalents in normality formula to evaluate the normality of the solution. So hopefully my dear students, you got the question. So let's move to the second numerical. Second numerical is saying, the first numerical was a bit confusing. Please do pause the lecture and see the question how I have attempted it. So let's move to the second numerical. In the second numerical, the question is saying, calculate the number of molecules of oxalic acid in 100 ml of, first of all, the volume of solution. It comes out to be 100 ml of 0.2 normal, means my normality comes out to be 0.2 of oxalic acid solution. First of all, I'm putting the formula for normality. Normality comes out to be gram equivalents of solute divided by volume of solution, and if it is in ml, I have to multiply my formula with 1000. What's my normality? It's 0.2. What's the gram equivalents of solute that I have to calculate, and what's the volume of solution given in the question? That's 100 ml. It's 100 into 1000. The gram equivalents of solute comes out to be 0.02. First thing, I calculated the gram equivalents of the solute. So let's come back to the formula of oxalic acid. What's the molecular formula of oxalic acid? It was given in the previous question. It's COOH bond COOH dot 2H2O. The molecular weight of solute comes out to be 126 grams. I have evaluated this molecular mass in the previous question. So what's the n factor again over here? It's same 2, because we are having 2 ionizable hydrogen in the molecular formula. It comes out to be 2. Now here, first of all, I am calculating equivalent weight of solute. Equivalent weight of solute is molecular weight of solute divided by n factor. What's the molecular weight of oxalic acid came out to be? It's 126. What's the n factor? It comes out to be 2, and it comes out to be 63. Now let's come back to the gram equivalents. What's the formula of gram equivalents? It is given weight of solute divided by equivalent weight of solute. It is equal to the 0.02. So what's the equivalent weight that we have calculated? That is 63. We have calculated our equivalent weight to be 63, which I will put it over here. So my WB comes out to be 63 equal to the 0.02. My given weight comes out to be 1.26 grams. Now the question arises, why I have calculated the given weight of the solute? Because I have to calculate the number of molecules of the oxalic acid in that given weight. So first of all, I am starting now with my previous topic called mole concept. What mole concept says? Molecular mass of any compound. What's the molecular mass of oxalic acid? It's 126 gram. Mole concept says that molecular mass of any compound is a collective weight of 6.022 into 10 raised to power 23 molecules. So 126 gram is a collective weight of 6.022 into 10 to the power 23 molecules. So 1.26 gram will be the collective weight of how many molecules then? It comes out to be 1.26 gram. It comes out to be 6.022 into 10 raised to the power 23 divided by 126 into 1.26, and it comes out to be 6.022 into 10 raised to the power 21 molecules. So my dear students, I got my number of molecules. Here I got this much number of molecules in 0.2 normal, in 0.2 normal oxalic acid solution with a volume of 100 ml. So my dear students, first of all, in 0.2 normal solution and 100 ml of it, how much weight of solute will be present in this solution? I have calculated that to be 1.26 grams, and then I have evaluated the number of molecules in 1.26 gram of oxalic acid solution. So my dear students, I hope you understood today's lecture. This topic was a bit confusing. If any of you has some doubt in these two numericals, please do leave the comment in the comment section of this lecture. I hope you all understood today's lecture. I have given my phone number on thumbnail of this lecture. If any one of you wants to book a paid one-to-one online class to clear doubts, contact me on my phone number. Please like, subscribe and share my channel to maximum number of students. Don't forget to press the subscribe button. Stay blessed.